Hi everyone, this is Sharan here. Welcome to my channel. The topic that we are going to see today is data transformation. Data transformation is a concept that has been frequently used in feature engineering. It is commonly used because the input data that we have in most cases is not readily usable for us to be incorporated into the model. So in many cases what happens is these input data that we have would have a lot of skewness in them. So to quote an example, let's say if housing price is one of the input variables, so these housing price data will be heavily skewed, meaning that the majority of the values would be in between the low to moderate value, but still there would be a few amount of very extremely high values for housing price, and we can't just ignore those high values and just use those values that are within the normal range to make or to build the predictive model, because if we do so, then the model would fail miserably when it comes to an housing price which is at a higher range. So we have to use all the data points. We need to ensure that we are retaining all the information that we have or that we have been provided, and we need to ensure that the data set is also being usable by the model. The reason why I'm saying this is, let's say if we use linear regression or logistic regression, there are some basic assumptions that have been made while using these algorithms. Some of the assumptions are the input variable as well as the output variable are linearly related to each other. So in other words, the dependent variable and independent variable have a linear relationship, and the data points that we have are normally distributed. So if we have some data point like housing price which is heavily skewed, we need to ensure that it has been properly treated before using all these models. In other cases, let's say if we are going to use models like algorithms like SVM, you might have a question. I need not worry about the actual distribution. I can just use the data as it is and then maybe use the SVM algorithm to make the prediction. But the catch here is, let's say, let's consider the same example at housing price. What happens is when we have extremely large number of values between low to moderate value and very few values for the rare events, if we use the data as such, what happens is the data would be trained for the lower to moderate values will be trained on these values, and when if an extremely rare event happens, the model is not being trained enough on those data, and hence there is a possibility for us to go wrong in those cases. And hence, by doing the transformation and ensuring that we have a normal distribution, what happens is it helps in actually making an accurate prediction. So this is the reason why we do the data transformation. Let's get into the tutorial and then learn few more details about what is the transformation and what kind of transformations are available to us, when to use what kind of transformations. So before going into the tutorial, if you like what I'm doing here, if you are learning something new here, please give a thumbs up and subscribe to my channel. Also ensure that you click on the notification icon to ensure that all my videos reach you on time. Let's go into the tutorial. So as you see on my screen, the first one is the question, why do we need data transformation? So here the question, here I'm going to start with the log transformation, and towards the end of the tutorial we will be also covering some transformation like inverse and square root. So please ensure that you watch the complete video. And as I mentioned, some of the reasons are in case of linear regression, the data assumes normal distribution, so we have to ensure that we do all those changes. And so this is another example which we covered regarding housing price. So coming to the data point as such, so this is how a normally distributed data would look like. So if you see this particular curve, it's exactly symmetric, like the left and right hand side are exactly same. So here in this case, what happens is the curve is positively skewed, which means that there is a long tail towards the right hand side, towards the positive end. And so this is a negatively skewed curve, so which means that there is a long tail on the negative side or the left hand side. So if I take a housing price as an example, so it is a data point which is positively skewed, meaning that we have a large number of values towards low to medium moderate range, but there would be some extremely high values towards the right hand side as well. So as I explained, what would happen is the model would be, if we use the data as such, even if we are not going to use linear regression or logistic regression, the model would be trained on a lot of data point that is on the low to moderate range, and there would not be enough data points on the extremely rare cases, and hence there is a possibility that we could go wrong whenever we have to make a prediction for an housing price, whenever we have been provided with an housing price that is extremely high. And hence, by doing the transformation and ensuring that the distribution is normal, it could be very helpful in our model. So while doing feature engineering, whenever you have data which is heavily skewed, you need to try some kind of a transformation like lot, inverse, or square root, or any other transformation to see if you are able to convert it into a normal distribution, and see how it helps in maybe building your predictive model. So coming to the next one, so what is a lot transformation? So lot transformation is nothing but we replace the value of a particular variable. Let's say if it is housing price, we replace that value of that particular variable with a lot of that value. So if we have 1 million for a housing price, so what we do is we use lot of 1 million, and then the new value would be the transformed value. So the next one is, when can we use lot transformation? So lot transformation can be used in all the scenarios whenever the data point is skewed. So as you see on my screen here, the data could be positively skewed or negatively skewed. Lot transformation will be very helpful when the data is positively skewed. For example, the housing price that I explained just now, there would be a large number of values towards the lower end, and there would be some rare events on the higher end as well. So in those cases, lot transformation will be very helpful. It can even maybe transform your data into a normal distribution or close to a normal distribution. And second point is when we can't use the lot transformation. So lot transformation cannot be used if your data points has 0 or negative values. So if it contains 0 or negative values, then if we apply lot on those values, it might become infinite, and hence we need to ensure that if we are going to use lot transformation, we need to ensure that the data point is always positive. And lot transformation would be ideal when the data is positively skewed or skewed towards the right hand side. So coming to the actual tutorial, so in order to use, what I'm going to do is I'm going to use the Titanic dataset, and some of the packages that are required for us are NumPy, Pandas, Seaborn, and Stats package, as well as Matplot library to make some few visualizations. So what I'm going to do is I'm going to import all these packages that are required for us in order to do this exercise today. And second one, I'm going to read the training data set of Titanic, which we have covered during the initial part of exploratory data analysis and feature engineering. So you should be aware of all the variables. If you are not familiar with all these variables, then maybe you can move on to the day 41, where we started the exploratory data analysis and feature engineering to get a better understanding about what these variables are. But if you are good enough, if you have enough knowledge about all these variables, then it's okay, we can proceed. What we are going to do is we are going to select two variables from here, age and fair. The reason why we are going to use only these two variables are because these two variables, we know that there was a lot of skewness in these two data points. There were extremely large number of fair on the lower end, and still there were like extremely high values to coming up in the data point. Similarly, when we take age, a majority of the passengers were like maybe close to 30s, but there were few passengers who were in their 70s and 80s as well. So these two data points had some kind of skewness in them. So we are going to see how we are able to use lot transformation or any other transformation in these cases, and then see how we are able to transform the data close enough to the normal distribution so that it can be helpful in our mind, while building the model. The first one is doing a box plot. So by doing a box plot, what happens is, as you see on my screen, we are able to clearly point out the outliers. So here we are able to see that the normal range for an fair would be like maybe less than 75. I'm not very sure about the units, so let's just keep it as numbers, less than 75. but we can see there are some values which are over 500 as well. So we can see that there is an extremely large number of outliers too. So these values need to be treated properly. We can't just ignore all those outliers. If we ignore all those outliers, then the model performance would be really bad. And we can't use these data as it is, because if we are going to use linear regression, so then this breaks the basic assumption that there should be a linear relationship and the data should be normally distributed. So even if we are going to go with like any other algorithm, so even then what happens is, in this particular case, there is extremely large number of values towards the lower end, and hence there is a high possibility that if we directly use these attributes as it is, it might not be good while building a predictive model. So we need to ensure that these data points are being properly treated. The next one is doing an histogram. Doing an histogram will give us a clear idea about the distribution. So as you see here, so this particular curve is positively skewed towards the right hand side. When we say positively skewed or skewed towards right hand side, you might have a question like the curve is on the left hand side, but why we call it as positively skewed? So we call it as positively skewed because there is a long tail on the positive end. So there is a long tail, there is extremely large number of cases, and then which makes the tail long on the right hand side. Hence it is called as skewed towards the right hand side or positively skewed. And so we can clearly see this data point is skewed. And then as we saw in the introduction, so this one appears to be a really good candidate for lot transformation. So before transforming the data, what we can do is we can do an QQ plot. So QQ plot is nothing but a quartile plot. So this is a plot which can be very helpful for us to check if the data point is following a normal distribution or not. So as you see here, so there is a red line here. So if the values, all those blue dots here, if they all exactly fall on the red line, it means that the data point is perfectly normally distributed. But what we see here is we see that there is an extremely large number of values on the higher side of the curve, and there are some values towards the lower side, and then there are some extreme values on the higher side of the curve. So we know for sure that in these cases the data is heavily skewed. So it's kind of like reiterating, like we already saw the distribution, we know that it's positively skewed, and then we are using QQ plot in order to reiterate what we are trying to say. So we are very sure that the data is definitely not normally distributed. So this QQ plot will be really helpful after doing the transformation to check if the data is getting aligned to a normal distribution. So the next one is we are going to use logarithmic transformation. So when I use numpy.log, so it means that it is a natural logarithm. So if I specify 10 here, so it means that I'm using log to the base of 10. So what I'm going to do is I'm just going to use natural log here. So I'm adding +1 here because if the data has some 0 values, if we use log of 0, then it might lead to infinite value. So what I'm doing is I'm adding an 1 here to ensure that that doesn't happen. So I'm adding an 1 and then converting the values into logarithmic value, and then I'm printing those values here. So this is how the fair value would look like after doing the logarithmic transformation. So after doing the logarithmic transformation, what I'm going to do is I'm going to use histogram in order to see how the distribution right now is. So as you see here, the data initially was heavily skewed, and then now it is maybe trending towards a normal distribution, but it is not a perfect normal distribution, because as you see, it's still, there is some skewness. It's there is a long tail on the right hand side, and there are some values on the extreme left as well, like for 0 values too. And hence so I would say the logarithmic transformation was maybe slightly helpful, but it's not really, like, it's not making the data into a normally distributed value. So maybe we can reiterate or we can check this using the QQ plot as well. So by using QQ plot, we can see that the values are not exactly on the diagonal. So there are still some values which are over and below the curve, and hence what we can say is that logarithmic transformation is helpful in maybe reducing the skewness that is present in the data point, but it is not making them into a normally distributed value, it is not changing them into a normal distribution. So having said that, maybe let's try the same thing with age and then see what's happening. The reason why I'm going to repeat this with age is there is something that I want to show you. So if I take age, so this is how the box plot would look like. So you can see that there is some number of outliers in this data point, and what we are going to do is we are going to do an histogram. So this is how the histogram would look like. So here, if you see, the data is not heavily skewed, that the right hand side doesn't have a long tail, so it's kind of like a very short tail. So in this case, if we are going to use log transformation, let's see what happens. So what I'm going to do is I'm going to do a log transformation and then plot the data. So what happened is the short tail on the right hand side has now moved towards the left hand side. So now there is a long tail on the left hand side, so this becomes relatively skewed data. So this is what I wanted to highlight here. So when your data set is not suitable for log transformation, and for example in this particular case age, it wasn't heavily positively skewed, there was a very short tail on the right hand side, and when we try to apply log transformation on this, what happens is the data becomes heavily skewed towards the negative side, and hence might be doing log transformation on this particular variable might be very harmful while building the predictive model. And hence before using any transformation, you need to ensure that how the data is distributed. You need to know whether it is suitable for us to do the transformation that we are trying to apply. And then the next one is, apart from log transformation, what are all the various other transformation that can be helpful? So some of the transformation are inverse, square root, and maybe you can also come up with your own transformation and then try to apply it on the data, see if you are able to convert the data into a normal distribution, and you can see how helpful it is in building the model. So the next one is the square root. I just want to show you how a square root transformation would look like. So when I use a square root and then if I try to plot the square root, so you can see the data point for like when I try to apply square root on fair, it is still like it does have a long tail on the right hand side. So I would say the square root in this particular case is not helpful. Maybe logarithmic transformation was quite helpful in maybe converting or transforming the data close to normal distribution, but square root is definitely not helpful at all because it still has a very long tail on the right hand side. So these two are some of the transformation that can be used in many scenarios. You can also come up with your own transformation. So the exercise for today would be to see what other transformation can be very helpful in this particular case, in maybe converting fair into something that is normally distributed. In some cases, what happens is any of these transformations might not be helpful. Maybe you need to convert these values into categorical values. For while doing the exploratory data analysis from day 41 to 43, so what happened was we used converting the fair attribute into a categorical attribute using qcat, and that was really helpful because while using quartile, what we were able to ensure was that we are able to ensure that the value, whenever the values are densely populated towards certain portion, we will have smaller ranges for those portion, and then whenever the values are partially distributed, we will have a larger range for those portions, and hence we are able to transform that into equal portions, because like if I take fair as an example, like maybe fair between 5 to 10 as well as 100 to 105 might appear very same because the difference is 5. Between 5 and 10 there is a difference of 5, and 100 and 105 there is a difference of 5. But what happens is between the value 5 and 10 maybe 70% of the values fall into this particular range, and between value 100 and 105 there could be just 1 or 2 values falling into that particular range. So even though mathematically they do appear similar, while using it for the model, we can't take it as granted. We have to ensure that it is being transformed properly. So So in this particular case for fair, the quartile cut appears to be like a best method for transforming it and making it usable for building the predictive model. You can also try to come up with maybe some other few transformation and then see if you are able to force or convert this particular attribute into a normal distribution. And that's it for now. I hope you would have learned something new today. If you have learned something new, please give a thumbs up and subscribe to my channel. And please don't forget to click on the notification button if you are interested in knowing about data science, or if you are interested to hear about data science related topics. That's it for now. Bye. See you on the next session.